All right, if there's no question, we're going to start. In the last class, we considered how to upload our data sets on uh, ChatGPT. We also did some cleaning, pre-processing on Excel in the last class, and then we ran exploratory analysis. We also uh, visualize our data set. Now we'll be taking it further today, and then I listed some statistical tests that we may likely touch one or two, and then in the subsequent class we'll look at other ones. So we'll touch a brief of descriptive as we did in last class, and thereafter we are going to move on to t-test, z-test, chi-square or official exact test, ppmc, spearman rank, Kenda Taubé, Manyu Watney, Kruskal-Wallis, ANOVA 1 and 2, ANOVA with replication and without replication, and COVA 1 and 2 as well. And then we have regression, linear regression, multiple linear regression, logistic regression, ordinary least square regression. Okay, it is important to understand the type of data sets that you are using before proceeding with your analysis, and that is why I have a particular data set I'm going to show to us tonight before we proceed. So I'm going to share my screen so that you can see the data sets, and then I will explain the conditions that you need to meet before running t-test and z-test, and then we look at the data that you are using respectively. So let's look at that briefly. So for the purpose of this training, one of the things I'll be doing is to be using live data with you, not just cooked data. Is a live data, a research data that was sent to me for analysis. Okay. Now, if you look at this data set, I believe you can see we have the names, we have ages, we have gender, we have occupation of parents slash guardians, we have number of households, access of drinking water, we have reasons for visitation to water body, we have observation of blood during urination, visitation to clinic slash hospital, and then previous treatments, then the results. This individual used two methods for identification of this infection, that is cattle kits and microscopy, that is from the stew. Okay, so the individual used these two methods to identify infection in the sample collected. Actually, the infection is when you see children urinating blood. So the essence of this kit is to identify if actually those infections, that the diseases exist in the respondent. Okay, so that is just the essence of this sample. So we'll be using this live sample, and then I will have to explain if you are using ANOVA, sorry, if you are using t-test, z-test respectively. Now, if you are to use t-test for your analysis, you must understand that your data must follow a parametric distribution. What do we mean by a parametric distribution? The data must be normally distributed. It must be collected from score, okay, actual score, like student score 10, 15, 20. These are score, okay. They are not assumptions, they are not maybe symbols, okay. Or probably you went to the lab, like this woman here who went to the lab to run an experiment and then collected sample, sorry, observation. Oh, when we tested the sample, this is what we observed. There's traces of infection, there's traces of these ailments in the sample collected. Okay, so if you are you are performing an experiment in the lab, Such data that you are collecting is a parametric data. Okay, is a parametric data. Another thing we must also note when we are running for t-test. T-test basically deals with two variables, that is two groups rather, like your gender, male and female. This is two groups. Okay, the same thing is applicable to z-test. So when you have just two group, we said that okay, you can use a t-test and you are testing for significant. Okay, when you are testing for the significant difference, you are comparing between two groups. You use your t-test or your z-test. That is for parametric. Now for non-parametric, we have Man Watney U, we have Kruskal-Wallis as well. These are non-parametric tests. Okay, and then when you have more than two groups, okay, when you have more than two groups, for instance, let's assume this age, you have more than two groups, 0 to 10, 11 to 20, 21 to 30. That is three groups under age. Okay, when you have more than two groups, we said you can use ANOVA. Okay, ANOVA is also used to test for effects or relationship, as the case may be. All right, so these are different knowledge that you need to have at the back of your hand when running analysis or as a statistician. So now looking at this data set, okay, if you look at it, you notice that like this age is two group, okay, gender is two group, occupation we have more than two groups, okay, the number of household, this is a continuous variable, it is not categorical. Number of household is continuous. You see, we can see 5, 4, 3, 6, 2, 4, 5, 5. So this data that we have in number of household is continuous variable. It is a continuous data. It is not a categorical data. Okay, so we must check all this to be able to determine the type of analysis to run. Now, if you look at source of drinking water, okay, at this ones too, we have stream slash well. Then that is those that they are saying that they drink well and they drink stream as well. And if you scroll down, we have let me scroll down. Let's see if under this, okay. Virtually for this group of people in this local government, this Obioju local government of Benue State, all the respondents here said they drink stream and well. Okay, then reason for visitation to water body, say is for bathing, for washing. That is the two options there. That is what they are using it for, bathing and washing, and it's general for all of them. Okay, now let's move on to the next variable, observation of blood during urination. There is negative. Then visitation to clinic and hospital, you see we have no and yes. So this is categorical. We call this nominal variable. When you have two options, we say it is nominal variable. Positive and negative is nominal variable. Gender, yes or no, is nominal variable. Okay, but when you have more than, maybe when your data is now rank, okay, we said it is ordinal variable. For instance, strongly agree, agree, disagree, strongly disagree. That is a rank data. That is what we call a ordinal data. All right. So basically, if you look at this now, this is a nominal variable. We have negative here. Here is 2 plus, meaning that it is existing. Then in the other sample here, we have negative, we have that is positive. All right. So now this is our data set. So before we proceed, I want to ask us a few questions and I want us to answer. So I said we are comparing the age and gender and then comparing the results from the samples. All right. So for tonight, we'll be using our Julius AI. In the last class, we used ChatGPT. Today, I'll be showing us another AI too. That is Julius AI. So if you are with your system, you can search for Julius AI. Then you click on free registration and then you put in your email, you log in, then we can start. if you can do all this with your phone too, okay? You can enter Julius AI on your phone and then you sign in with your email free, okay? And then you upload the data set. I can send this data set to us too. This is my Julius AI. I've been using this for quite some time. So if you look at my left hand side here, you see so many things I've done. It's
I can't
used.
see it. I can't. Okay, I'm seeing a screen now.
Okay. So I guess it's network. So by the left hand corner, you see your thread, your workflow, files that you have uploaded before. If you have been using it, you can see all of them there. You have inbox, respectively. Then once you come in, you see what do you want to analyze today. While register, I told them that I'm a data analyst and this is what I want to be doing with it. Okay, so and that is why you see the message. What do you want to analyze today? Now we have quick visualization in case you want to visualize, data cleaner, significance testing, time series analysis, extract tables. Okay, now these are different things you can do. But now what I want to do is I want to upload my file. So I'll click on this attach, upload file. The file I want to upload is in my document. So let me look for my documents. Okay, I've uploaded I've uploaded my data sets. Now the Julius AI is analyzing, and if you look at it now, it has displayed my data set for me. So if you can look at my screen, you can see it's saying what are the common, how do age, it's even suggesting how do age differ from, how do test varies results, what reasons different, different suggestion, but I will decide what I want to do since I have my goals. So this is my data set. It has displayed it for us, and that is what I have in my Excel. Look at it. Okay, let me pause. So from the objective, we said that we want to compare to see the significant difference between ages and gender. Okay, and I said this that when you have just two groups and the data is parametric, we use theta. If it's not parametric, we use manual Watney. Okay, but for the purpose of this class, I will not wait until when we have maybe parametric data and non-parametric data. I will just go ahead and then use any of them. So let's just pick this. I'm going to write in this down and I will say compare let me look for that results, what the name there. So because one thing is you must get the name correctly, the name on that data set, that is cat kit, something like that, and then microscopy.
Catching and microscope.
Yes, we are comparing the two together. That we are comparing the results, the two together. I'll just copy that is urine. It's okay. Compare this and where is it? Um, this sorry, two microscopy. Let's go. Where is it? And this using uh, compare urine and stool using T tests. And let me click on enter. I'm waiting for my results. And then the AI now is comparing, okay, and it uses a Python code. So to generate the Python code and then it will implement it. We now have our results now. We have our results, and let me look at it. He said, uh, here are the key output. T statistics is minus 27555. Show a T statistic of approximately minus 273. Okay, approximately. Okay. The p value, it is significant, 0.008. If we are comparing it with 95% confidence interval, is 0.05. Okay. The count for urine results in urine result count. Let's scroll down and see. Now, this is a table. It said indicate most are negative with some additional non-standard responses. The count for stool results in stool result count and continue. Okay, you have negative POS, whatever. Then said also mainly have negative with some pause, that is P positive. So in summary, the t-test comparing the binary outcome of cattle-cat kits and stool microscopy results yield a t-statistics of approximately minus 2.73 and a p-value of this, which suggests that there is a statistical significant difference between the two tests, between the two tests. Okay, so um, I believe you can see my screen. Let me pause and then let's wait. Okay, and I'm going to prompt it that under the result column, let the empty cells, or those one that contains 2 plus and like, there should be positive, there should be replaced with positive. Okay, so that it can be 2 column. Then you will now run it again. Let's just quickly look at it. Let all the cell in results that are not negative,
Let's go.
be replaced with positive. Okay, and then
Let's go.
compare the results between stew and urine. Urine.
Mr. Stanson, please,
Yes,
can you after typing the prompt, you want to prompt the AI.
I should put it on this
So
Abi.
I say you can
Yes.
copy and put it, yes.
Okay. Let me quickly do
Mm,
that.
so that we will be on the same page.
Yes. I've sent it.
Okay, thank you. I've seen it.
Okay. Let's run this one.
Let all this that are negative be replaced with positive, and then compare the results between stool and urine using the, the test and X test that there is that this result indicate there is no statistical significance
Yes.
between the urine and the stone test results.
Yes.
So after that thing I posted on the platform,
Mm.
so I got
Include degree of freedom value, then mean value, standard deviation to the t-test table results. Let me send this to the chat before I send. Okay. He said, let's compute a group-wise summary statistics. That is a sample size, the mean standard deviation for the recorded urine and stool result, as well as include degree of freedoms value in the t-test results. Create a summary table that shows the following for each group. All right, let's see. Just wait for it. I'm still waiting for it. We have looked at the types of an statistical test and how to select different tests. And tonight we used Julius AI to, one thing we did was we did data cleaning with it. We replaced the empty cells that were not showing what we want with positivity, and they are positive rather. And then we now went ahead to compare the result from urine and stool, since this contain two categorical variable, or what they call binary data. Okay, to compare if there's a significant difference in their tests. And then from the results, both myself and Mr. Moses, it shows that both of them, they are not statistical different. There's no difference between the results, meaning that they are giving the same output. So there's no significant difference between their results. That is what it meant. And then we were able to prompt it to give us our sample, our mean, our standard deviation. Okay. We even ran for Z test as well. Okay. Even though Z test is your sample must be above 30 to be able to run Z test. But for now, we are going to stop here.